All right. So I've got these two angles are complementary. I'm repeating 2 to say 2 and 3 are complementary. Prove that 1 is congruent to 3. And a lot of times it helps to have a sketch. So I'm actually going to draw this out. So here I've got angle 1 and angle 2. And they add up to a right angle. And then there's angle 3. They add up to a right angle. And I want to show that these guys are going to be the same, 1 and 3. And it might not seem the easiest thing to show until we actually start writing the proof. And I like this one and the congruent supplements theorem because I think the proof themselves makes a really good case for why it should work. It helps illustrate what the theorem says. For example, let's get going on. Let's get started. We'll start off with our given. Angle 1 is congruent to angle 2. No, angle 1 and 2 are complementary. Sorry. I wrote one thing. I said something else. And angle 2 and angle 3 are complementary. Those are both given. Now, from that, what do I know? If I make the statement that 2 angles are complementary, what should ping pop up in your head? And what? They be more specific in your language. Not they equal 90. What do you really want to say? They add up to 90. Measure of angle 1 plus measure of angle 2 equals 90 degrees. Now the reason I'm particular with that is if you say they equal 90, that could also be mistaken for angle 1 equals 90, angle 2 equals 90. And you got to be real careful with that. So that's what rule says that. If I say they're complementary, therefore they add to 90 degrees, what rule connects it? Definition. Complementary angles. And I can say the same thing for angle 2 and angle 3. We're going further. I'm going to come down here, and at the bottom of my proof, I'm going to write angle 1 is congruent to angle 3. And leave myself some space. And the reason I'm doing that is I want to remember that that's my goal. Think back to the activity we did, which is our metaphor for all of this. You can't plan your flights unless you know where you want to land. You're always looking, how do I get to that spot? Otherwise, you end up flying all over the U.S. So the same idea with a proof. Know where you want to end up. Sometimes it's hard to see how to get there, so you just start doing stuff. You know, I got to fly somewhere. I'm just going to fly and see where I land. Sometimes you can see real clearly where you're headed. Now, this down here has a 1 equals 3. 1 congruent to 3. They're on opposite sides of an equal type sign. Can I take this and create that? Can I get 1 plus 2 equals 90, and 2 plus 3 equals 90, and get something similar to that? Now, is the hand up? Yeah, what you got? Okay, I am not going to argue with your statement. I'm going to argue with your justification. We'll write down the statement first. 1 plus 2 equals measure of angle 2 plus measure of angle 3. Now you said that's because all right angles are equal. I'm going to say it's not quite it. But you're right, though. 1 plus 2 does equal 2 plus 3. But there's a better rule for saying why I can match them all up. Here's a little bit of a hint. Have we seen anything that looks like this? A equals B, C equals B, therefore A equals C? The what? Not law of detachment. Laws of detachment have to do with if-then statements. In syllogisms, it looks like law of syllogism, but again, that has to do with a logical argument. Transitive property of equality. Oh, measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. I'm just taking these two and combining them into one. Now, the transitive property of equality is the one that says if I can make a bunch of things match up, I can link the things that are matched. And this is kind of an important property we're going to use a lot with the algebraic side of these proofs as I work my way down them. You can also call this substitution, technically. Now, can I get from here to here? Or something close to that? I've got 1 plus 2 equals 2 plus 3. Can I get that down to just 1 equals 3? Chris? And what rule says I'm allowed to do that? To subtract 2 from both sides. Subtraction, property of equality, yeah. And now this last one, whenever I say that because the measures are the same, I can conclude they're congruent. That's the definition of congruent. We haven't talked about that a lot yet this year, so I'm going to kind of keep nudging you towards that idea. Measures equal, therefore congruent, definition of congruent, and vice versa. If you say two things are congruent, therefore their measures are the same, that's the definition of congruent. And that's what I set out to prove, so I'm finished. How we do? Questions? Where are we getting stuck in here? I'm not sure lack of sleep can be listed as an official reason for struggling, so we'll take it.